right. This slide is what we wrote down yesterday. Yesterday we talked about fast twitch and slow twitch fibers and what their characteristics were. And you did some activity to determine whether you had fast twitch or slow twitch fibers in different parts of your body. I'll just remind you that if you need assistance answering any of those questions, you can ask me in class, you can come to scheduled help, but that you need to finish that assignment this week. Now, we talked about fast twitch and slow twitch fibers. Today we're going to focus on the word twitch and what that is referring to. And a lot of what we're going to do is look at how we could visually represent a muscle twitch by looking at some different types of graphs. So if you have the printed out notes, you would notice that the next slide is just empty because we're going to do a little bit of drawing here. And I think that it's well worth your time to actually have to draw these rather than for me to have just printed one in the notes for you to look at. The first thing that we are going to look at is something called a myogram. Myo is one of those prefixes that you see on words that have to do with muscles, and a gram is very often some sort of graph. So a myogram is a muscle graph. And we're going to draw a couple of different types of myograms so that I can show you a few different things about your muscles and what happens when they twitch or they contract. So the first thing that we'll draw is a graph of a very typical skeletal muscle when it's contracting. The graph will represent one twitch or one contraction of your muscle. Now when you're drawing a graph, it's really important to always recognize what is on each axis. On the y-axis, we have force of contraction, and I put an arrow going upwards to indicate it's going from a small number to a big number. I am not particularly concerned that you memorize an actual number because it would be different depending on the muscle. We're going for a more generalized response here. On the x-axis would be time. And so our first myogram is going to show us what it looks like when an average, typical muscle contracts. The first thing that you would notice on a myogram, very typically, is actually a flat line, saying that nothing is changing in terms of force of contraction. This flat line here is what we call the latent period. Now the word latent, it kind of sounds like late, hey? It has late at the beginning of it. It means that there's like a space or a gap between when something happens and your muscle actually starts contracting. So the idea would be that some sort of stimulus happens, and then there's a pause. There's a space in time. It's not very long, hey? It's milliseconds. But there's a space between whatever stimulus is making your muscle contract and when it actually starts contracting. Anyone know why there's a space in time there? What has to happen between, say, you feeling that the stove is hot and you moving your hand off of the stove? Yes? Right, nerve messages. And some nerve messages take longer. The hand on the stove is a pretty quick one because it's just a reflex. But sometimes the stimulus is me saying out loud, please get up out of your desk. That requires your ears to hear, your brain to process language, and then you to decide that you're going to follow my instruction and get up out of your desk. There's a latent period there. Now, the rest of the graph shows you the typical muscle contraction graph. So, on the left is contraction, right? So it's going up. On the right is relaxation, because now it's going down. So this is a very typical graph for a skeletal muscle. There's a stimulus, there's a latent period, then the muscle contracts, and then the muscle relaxes. Now I'm going to add a couple of more lines to this existing graph to show you that not every muscle is made up of the same type of muscle fiber. So I'm going to leave this black line there, like that will be my original line, and we're going to call this one, as an example, your calf muscle. It's a pretty regular muscle. Now your calf muscle is a good example of a muscle that is intermediate in terms of its composition of fibers. So not all fast twitch, not all slow twitch, but those intermediate twitch ones that are sort of in between. But there are some muscles whose graph would look a little bit different. If I were to have a fast twitch fiber, it would look a lot more like this green line. It would happen sooner, and the space sort of between contraction and relaxation would be narrower. So it looks a little bit pointier. A really good example is your eye muscle. That's a fast twitch muscle. And then we would add, of course, a slow twitch muscle. A slow twitch muscle, unlike the first two, would be really drawn out. So it would go up slower, it would go down slower. So if you look at how wide each of the little hills are, for a fast twitch muscle, it's really narrow. For an intermediate twitch muscle, it's a bit wider. For a slow twitch muscle, it's quite wide and spread out. The muscles that are deep in your leg, like your soleus muscles, that would be a good example of a slow twitch muscle fiber. So on this graph, we've really talked about two things: what a myogram looks like, and also what it would look like for three different types of muscle fibers. Now before I do the next type of graph, does anyone want to ask any questions about muscle fiber types and a myogram? I love graphs. I like to put them on tests. I like to make questions about them. Since I went to all this trouble of making you draw this graph, it is very likely that I will make a graph such as this and put it on a test that you would have to do. Very likely. Now what I'm going to do next is I'm going to erase the inside of my graph but keep the outside. I'm going to keep the blue part because I'm going to show you another myogram, but this is going to be for a specific circumstance. So in my new myogram, instead of having just one stimulus like we did in the first one, I'm going to show you a situation where your muscle is not able to relax because there are a lot of stimuli coming at it. So it's still a myogram, so I still have force of contraction and time as my two axis labels. But this time, my graph is going to look something like this. It's going to go up and up and up. It's kind of going to flatline at the top, and then it's going to sort of slowly make its way down. So it's a funny looking shape. And the idea would be that there are many stimuli. So each of these little arrows, and now the exact number is not the crucial part here, it's the idea of repetitive stimuli. But each of those little arrows represents some stimulus that is affecting the muscle. So your muscle is getting some constant signal that it needs to contract. When I look at a myogram like this, there are some different words that would be associated with it. This section here is called the summation section. And if you think of what the word sum means, it means I'm adding together. This is where the force of contraction sort of adds as you go. Every time the stimulus comes back, I add that to the force of contraction I already had. Then you get this crazy little wiggly line at the top. This is called tetanus, this part at the top. You might have heard of tetanus before. You can get a shot for tetanus. And so the word tetanus refers to this idea up here of a prolonged maximum contraction. So when your muscle is in tetanus, it means that something has told your muscle to contract, some signal has happened, and then the signal keeps happening and keeps happening and keeps happening. And then your muscle hits a point where it says, that's it. I cannot contract any more than I already am. Your muscle stays contracted for a little while. It probably hurts, and then your muscle relaxes. This section down here is called the fatigue section. That's where your muscle can't handle it anymore. It doesn't have any more energy to keep contracting, so your muscle gives up. And on this side, the stimulus is still happening. But your muscle doesn't care because that is the most that it can contract. So yesterday, when I made you do a wall sit, and at some point you had to give up because you couldn't do it anymore, I made your muscles be in tetanus. And then fatigue because they couldn't handle it anymore. Now that's only true if you gave up because you actually couldn't do it anymore. If you gave up because you were bored, then your muscle probably didn't experience fatigue. But this is what happens on a graph when we're talking about muscle fatigue. Does anyone want to ask any questions about what's on this one? So these are the graphs that I wanted us to actually draw together. The other things that I wanted us to do about graphs was to answer a few questions that are in your textbook. Some of them are about myograms, and some of them are just about regular graphs. But they're all about muscle fiber types and muscle contraction. So this is just a simplified version of what's in your textbook. Your textbook had a bunch of variations for person A, let's say. This person has more fast twitch muscle fibers than slow twitch muscle fibers. So in your textbook, there were several examples of people that had more fast twitch than slow twitch. And I'll just summarize who they were. First was the person with a spinal injury. We would sort of make an assumption that if you have a spinal injury and are unable to move your limbs, endurance activities are kind of out for you. So you can only make rapid muscle movements, things like blinking, swallowing. Now, spinal injury would have been the one farthest to the left. Close second to that would have been the sprinter. Now the sprinter definitely has a lot of fast twitch muscle fibers, but the sprinter had a little bit more slow twitch muscle fibers because they would have some endurance muscles even just from their daily life. The next person that would go on this side of the graph would be our sedentary person. So the S's, hey, the spinal injury, the sprinter, the sedentary person, the couch potato. Someone over here was discussing this, and they correctly identified if you are a sedentary person, what kind of movements are you making? You get up from the couch. That's a quick movement. You sit back down on the couch. You lift up the remote control, or you put it back down. Unless you're doing like remote control aerobics while you're sitting there on the couch, you are generally using your fast twitch muscle fibers more. Now, right in the middle here, this is your average, regular person. So the idea is that without specific training or without a lifestyle that encourages one type of fiber over the other, most people have an equivalent percentage of fast and slow twitch fibers. You have some muscles for strength and some muscles for endurance. Now over here on the right, these are all the people who have way more slow twitch muscle fibers. So the person who was the farthest over, according to your textbook, was the extreme endurance person, followed by the marathon runner. To me, when I looked at those, I was like, I don't know how I would ever tell the difference between them. They both sound like people who run for crazy amounts of time. And then you had the middle distance runner. So the idea being, all the people that were on the right side did some sort of running, some sort of endurance activity. Now it doesn't have to be running. This could very easily have been replaced with riding a bicycle. It could be replaced with something like skiing. Anything that you're doing over a long period of time, walking, running, swimming, biking, skiing, doesn't have to be running. But if it's happening over a long period of time, would put you on the right side of the graph. So you could expect me to show you a graph like this and me to ask you a similar question. Who goes with each part on the graph? It would make an excellent numeric response question. Here's 3 people on the graph. Here's their descriptions. Who goes with which part of the graph?